So here were the objectives that we went over, what we want to accomplish. Again, we want to show you what we've been doing, but we also want to get feedback from you and have a discussion. Okay, so this was the slide on the basic methods that we've been utilizing. And probably the key here is that our approach in the software that we have developed integrates a number of different databases. It integrates information on people's water use, information on the type of landscape material that they have, and integrates information from reference evapotranspiration that gives us an idea of how much water those landscapes need. Again, here's where we're looking at how appropriate is their use, how do we sort of benchmark it so that we can distinguish between ones that are high users, ones that are fairly efficient already. We've got a capacity to conserve calculation that we've developed, and this software application that hopefully you are going to get a chance to be able to see. We've already talked about this, but the appropriateness, we grant, at least in our approach, users to have a whatever type of landscape they have, a traditional legacy landscape or maybe a low water use landscape. Whatever they have, we want to see how efficient they can be to water the plant material to meet its needs. In terms of benchmarking, getting used to a different screen. In categorizing, and we're going to talk about the landscape irrigation ratio in the next slide, we've really been searching over time to get good data to work with. We've got a couple of test locations where we've worked, and its availability, accuracy, and completeness is really important to the whole approach. We can make different assumptions, and so we do want to stress that there are policy decisions that are embedded in how the calculations are made, and that cities could choose to use it in different ways, depending on how generous they may want to be in the calculation of capacity to conserve from the start. And so benchmarking is a part of the approach. Our capacity to conserve calculation is a landscape irrigation ratio, which basically takes the landscape water use as we estimate it from billing data, and then landscape water need and our estimates of what that landscape needs, depending upon the type of plant material that is identified through the aerial imagery. This LIR then is calculated per unit of landscaped area. And so obviously a LIR of 1 would mean that they're watering to meet plant need. A landscape irrigation ratio of 3 would indicate that they're watering 3 times as much as their plants probably need. The software application automates this analytic process that we've developed through a number of different research projects and allows us to display results across an urban environment. It facilitates the mining of water billing data, which is no small chore because the software and the ways in which water billing data is kept is not easily integrated into a GIS interface, and the software that we've developed does that. So we're hoping that you're going to get a chance to see a little bit more of the software application. Let me just mention a little bit about the assumptions and policy choices. We've wrestled with how we can best estimate landscape water use. How do you account for indoor use when you're in situations where indoor and outdoor use are combined in the meter data? How do you deal with bad and variable meter data? How do you find hidden problems that could be affecting water use, such as leaks, that may not be a behavioral problem that you would be trying to address through water conservation programs? And then how do we account for various sources of change other than people's intentional effects to use water more appropriately? And we've found that things like residential mobility and adaptation of weather that people make to weather year to year is affecting it. We're hoping that they can adjust and mirror what's happening in terms of weather. But we want to, partly this tool is a way to assess the effectiveness of water conservation programs, and so accounting for the different factors that could be affecting that variability is important. Landscape water need is the other factor in the LIR, and here is where we have to talk about how generous should we be in the calculations of landscape water need. There are different ways to use this various equations to calculate it, and so the questions are, do you grant the end user their existing landscape, rainfall, poor irrigation system distribution uniformity, or the fact that they may irrigate earlier or late in the season? Or do you use those as explanatory variables after the fact to explain the efficiency that you may be seeing in some locations and the overuse in other locations? So those are some choices in using the software. Currently, we're doing some work to extend the approach to deal with some of the analytic difficulties that we've discovered over time. One is that in many cities, the parcel boundaries do not include parking strips that contain a lot of vegetation that people nevertheless water. And so we have developed and put into the software a routine, a buffering routine, to allow it to go and identify landscaped area that may be and most likely is being irrigated, but that is not included in parcel boundaries. We want to make sure that software is universally applicable, but we recognize that it's going to need oftentimes to be customized for particular locations. We're attempting to integrate more analytic functions so that cities could do more temporal analyses as well as spatial analyses to understand what's going on in watering landscapes in the urban environment. And then we really want to match its functionality to cities' capabilities and incentives to use it, and we have realized that there is variability in cities' infrastructure and ability to use it. On our end, we've been balancing different utilities that we see in this tool. We developed it initially as a research tool, and it gave us this powerful independent observation of human behavior used in our analyses. We developed it as clearly with management implications for water utilities of how they could use it to profile water use by location, target conservation programs to the locations with capacity to conserve, how they could monitor results of conservation programs to test their effectiveness, and then how they could use the information to design water conservation programs and policies. More recently, we are transitioning to use it as an information tool, where the software now has a function that can provide individual users information on their landscape irrigation ratio for their location and their plant material. And so we have a function that it can produce these water use reports. And reflecting this information back to end users, we think is an important thing to do. Because we think it could be a motivator for conservation when there is the capacity to conserve. So we're trying to assess how much the approach and the software and the tool that we've developed can simultaneously serve all those different purposes and other purposes that cities may have in using it, and that's one of the things that we want to talk to you about today, hopefully if some of you represent some water utilities. So, this is the point at which we would transfer to a software demonstration, and we would like to show you what the software tool does.
Yeah, so this is the problem that we are having trouble with, and we did, of course, test this procedure prior to the webinar, and now in real time it is not working. We'll give it another go in a few minutes once we get some more instruction about possible problems. So maybe at this point, we could take any questions that you have.
Go down.
Keep going on the questions.
Okay.
And let me open the chat window.
Okay.
Okay. And see, if anyone has any questions, please enter them in your chat window. So there's the first one.
How did you automate the landscape delineation?
I'll answer that. This is Christopher Neale. The imagery was acquired with an airborne multispectral system with spectral bands in the near-infrared, red and green part of the spectrum. And that, after calibrating the imagery and producing the orthomosaics, that calibrated imagery was classified through supervised classification to extract then the landscape features, basically turf, grass, and trees and shrubs separately, along with some of the impervious surfaces like roofs and asphalt and concrete sidewalks and so forth. So that portion is not automated. It's done separately outside of the software, and the classified recoded layer, the end product of that classification, is what is imported into the environment that the software is running in ArcGIS.
The next question someone asked is, how often do you collect image data?
That's a good question. We've discovered with our work in the city of Logan, where we started this process back in 2004, that over time the classified layer gets dated. For example, there are lots that were empty in 2004 and that are now have houses built on them, and this leads to huge landscape irrigation ratios that are not realistic, because it's based on a patch of weeds or something that was growing there on that lot before the house was built and landscape put in. So you do sort of have to update on possibly a 2 to 3 year basis, I would say, to keep things current and account for changes in the landscape and growth of vegetation in these different lots within the city.
Logan City that we worked with in particular was now and then acquiring imagery from commercial overflights, but they did not always purchase the thermal layer. So one of the things, this is one of the capacity issues. Do the cities have the types of databases that they could utilize, could use in using this software? And so there would be some recommendations on the kinds of things they would need and how often they might want to be keeping that updated. It looks like we've made a transition, and Clay Lewis is going to speak now. Clay has been the one who has done a wonderful job in taking on the software program from some earlier developers and building a very nice architecture to carry it forward. So.
Okay, and this landscape water software is what you're seeing now. If you look at the tabs at the top, you'll see a property boundary, irrigation, evapotranspiration, land classification, and calculations. All those refer to inputs, and then obviously the calculation tab, what you calculate. For the property boundary, of course, you need the area, the plot of ground where someone's watering. And we have an example here of Logan City, and one of Christopher Neale's flyovers from 2004. We developed a routine, as Joanna said, that extended the buffers 40 feet, or how many ever feet you would like, around the parcels to pick up greenery. If you look at this image, you can only see the street around all the parcels. That's because the layer underneath picked up all the trees growing on the outside. We wanted to include this area because the tree crown covers the road and sucks up water from what people irrigate, but they're not getting counted for it unless you do extend the buffers. There's the traditional buffering routine that overlaps, but we had to do some processor-intensive calculations to remove the overlap and just have the extended parcel for the area. So that's one important thing on input. The next tab, we go to the irrigation data set, or this is the water metered input. And now there's a whole slew of formats that this can be kept in, but it's usually a database, whether it's CSV or tab delimited, Access, Excel. We have two examples, one in Weber Basin and the other in Logan, that you'll see today. And both of those were taken from CSV and Excel files. The first one that I'm going to show is the readings from the Logan City database. Their record spans from about 1997 or 1996 until present, and you can see there's flows, monthly flows, or consumption values in thousands of gallons for this customer. In wintertime use, they have less, and summertime use, obviously more. If we go further back in the history, there's some estimated data. That's what that E stands for. And so we don't actually know what they're using during the wintertime, and we might not have too many reads per year. So in some cases, only two, once in the spring and once in the fall. This program had to be able to take data that came from any time and really any format, and include estimated time periods and non-estimated, and even different times of season when they're reading, and be able to estimate what people need to use and also what they are using, getting their LIR, or landscape irrigation ratio.
I might point out that since 2008 or 9, Logan has started changing out the old manual meters to wireless meters, where now they can drive by on a monthly basis and have a reading done automatically. And so now most of the meters in Logan are read monthly, and of course that facilitates the processing of the data, and we can get much more accurate estimates than we could before, where the meters were only read twice a year. Okay. And it also allows us to estimate the indoor water use during the winter months. The typical irrigation season in Logan, Utah is from April. We started April and ended in end of October, though typically people shouldn't be irrigating in April because there's plenty of moisture from the snowpack melt and rains and spring rains, but some people, believe it or not, do. But by isolating the winter months, we can then estimate with this monthly meter data what the indoor water use is, and subtract that average value from the summer months, and then attribute the difference just to the landscape irrigation. Okay, and that's one of two options we have currently in the program. You can either select indoor water use or a secondary source, meaning you have both your indoor, your culinary water, and your outdoor coming from one source or from another. And in the case of Logan, it's an indoor for Weber Basin Water Conservancy District. The other example that we're going to show, they have a secondary source. A third option is the application efficiency. This you divide by the need, so this number is less than 1, or 1 in this case, which isn't achievable, of how much spread you can get over your lawn in your system, meaning your irrigation efficiency. And irrigation efficiencies can range anywhere from 0.4 to 0.8, but usually hover around 0.5 to 0.6. And I might add that this is one of those policy decisions that Joanna mentioned about earlier, one of those factors that you could modify accordingly. In this example, I have all the data input, but really you just add. This is an access file. There's a few formats that are inbuilt right now that you can load in, and you pick your field where you have a record date, and also if you have an estimated field that has anything other than a null in it, it will read and skip that value and sum it until you do get a value or a reading. Down here in this data grid view, you
There's 2 rows that are redded. That's because they've already been selected in the data and estimated field, so you can't change them. So all that's left, that's included, is the flow, and we change it to a factor of 1,000 to get it to gallons. Our next tab shows the Evaporation Database, which was obtained from weather station data in Drainage Farm. That's in the middle of the Valley of Logan, and it was assembled into a database. This is actually Weber Basin, and you have the average daily temperature and the total precipitation and the ETO for the day. And this was, even though it's shown daily, it was calculated on an hourly basis. Using this data, you can establish what different crops would need. And so it gives a reference transpiration and evaporation of whatever you have on your landscape and whatever you classify, which is the next tab. We specify a start and end date to the season. There are models out there that can automate that from the temperature data or other means, preferably soil. But then you pick whatever stations you want input. I'm working on a separate function where you can use multiple stations and use an interpolation scheme to cover your whole area, meaning going to the nearest station, weather station, or somewhat of an average. The land classification tab, you input a raster image and select the value field. Here you see we have classifications of grass, sparse grass, stressed grass, trees and shrubs, bare soil, asphalt and roof, concrete, roof and bare soil, water, and shadow. And those that aren't vegetated were given a plant factor of 0, whereas all the grasses were given 0.8, because we thought even if they had stressed grass, they were probably still applying the same amount of water. And since trees and shrubs use less water than grass, it was given a lower plant factor. Moving to a map in ArcGIS, we can see an example of one of Christopher Neale's flyover images, and this is in Weber Basin. Here's the multispectral image that you get from the flyover. I'll zoom in to an area so you can see it a little closer. Those are the houses and the road, and the trees and the cover. And when you classify it, you get these categories here. The grass and the sparse grass, if you look over on the legend on the left side. Just zoom in a little closer so you can see. Going back to Logan, this is what sits under the parcel, and when you go through the calculation in the program, you find out what's underneath every parcel, the percentage of it, and you times that by the proportion ETO with the plant factor on it. You sum that up for the whole area under the parcel, and you get a volume in gallons. And then you divide that by your application efficiency, and that's how you establish your need. Once you get the water database input from the meter data, you'll have your use, and use divided by need gives you your ratio, or landscape irrigation ratio, or the rate at which people use it. The whole calculation for all the polygons in Logan would take a few minutes, but I extracted a subset that I'll calculate now. So here we're calculating the area, and all these calculations are done in ArcGIS behind the scenes, and because we're using a spatial function, you have to have the spatial analyst extension enabled.
And I might point out that in the case of both Logan and Weber Basin, they had GIS departments and had we were able to get their GIS layers for parcel boundary and meter ID location and footprint of the buildings and other spatial information that we use. The parcel bounding in particular is what we cookie cut the classified image to get the amount of landscape on each parcel.
One nice feature of the program is that it's run on a daily basis. That's how the time steps work in the inside, since there's monthly data, there's annual data in some cases, and we have some hourly. So we sum anything less than a day to a day, or the program automatically interpolates in between redates to a day. That way you can specify any time period you would like. If you see in this data, it grids you here, and you can even have overlapping periods, and it will just sum for it. In this case, we only had one time period that we summed through from April 1st to October 31st. And here we'll take a look at the landscape irrigation ratios that we calculated. We are right now on the year 2007. We'll go to 2008, 2009, 2010, and 2011, just for a few examples of what the program calculated.
So if you go back through that again, you'll notice that the parcel that's in red down at the bottom has a ratio of 3.94, almost 4, which means that we estimate they're applying 4 times as much water than their landscape needs. And if you
that's my yard. I'm doing it right now during the rain.
So if you go back again, Clay, in the years, right? Can we do that?
Which year would you like?
Just keep going back. You see that consistently that property is high, while the other properties around it have variable ratios, but that particular property is consistently high.
21?
So that is most likely a leak, the one where it's 21, because that one year is such an outlier, and that would be one obvious thing you'd be wanting to investigate at that property.
That's back in 2005 as well, where we still don't have the automated monthly reads, and so there's a lot of estimation going on with only 2 reads a year, and so there could be several reasons why we have these high values or really low values. So put it back in a more recent year. Yeah, there we go. So this on a citywide basis allows you to identify high end users and target them for conservation programs, checks of their irrigation system. Many times they just need some help programming the automated sprinkler clock. A lot of what we've observed in Logan is that people start their season with a clock the way it was regulated from the previous summer at the peak, and they'll use that all the way through the fall and then start again in the spring with the same application rate. And it's in the shoulder seasons in the spring and in the fall where a lot of these inefficiencies occur.
One of the things that we found with water waste is it's often invisible because it sinks into the ground instead of accumulating like recycling waste. And so people often innocently overwater, and they really don't know how much the plants need and how much they're using in relation to that need. So as you saw the neighborhood, besides being able to identify ones that are high-end use in that the water applied exceeds the amount needed, you can also look at the neighbors and see that they are able to maintain landscapes with very similar aesthetics using a lot less water. So there are 2 dimensions of comparison here, one of the person's behavior to the local ecology and the other their behavior in relationship to others' behavior in the same area. So we've noticed outliers and individual high capacity to conserve on individual lots, but in looking across a city or a service area, you can also identify some areas where there may be high-end use across the neighborhood or higher than in some other areas that could be related to the site-specific context and factors related to wind or certain types of soils in particular areas, or certain aesthetic appeals, or areas that have new establishing landscapes that often use more water than much more mature landscapes. So it allows those kinds of analyses to occur.
We have a few questions that have been piling up.
Those are the same ones. So just as a reminder, if you have any questions, go ahead and type those in.
Just weave.
As you can see in this image, if you look into the, following my pointer, the more established older parts of Logan, you get more green, and up on the hillside, you see a few more red values and yellow sticking out. That could be because of higher ET on the mountainside. You have canyon winds coming in, along with a steeper slope and aspect. But you also have more wealth, too, on the side of the hill. So there could be a few contributing factors onto why they have higher LIRs than people in the valley.
And certainly they have a more rocky substrate to their soil in their backyards. This bench area has a geological, I mean, it's old shores of Lake Bonneville, which was a prehistoric lake. And so it's very gravelly and high infiltration rate, and a lot of sand and gravel in the soils there.
Okay, we're going to try and attempt to address your questions right now.
Oh, okay, let's try and respond to the question, are the plant factors that you chose in the model based on traditional crop coefficient approach, KC values, or did we make them up? Well, for turf, we use the traditional values for turf, and also Roger Kjelgren, who's our colleague in this effort, is a plant scientist and has done a lot of research with trees and shrubs, and the 0.5 factor that we're using is an average value for a broad range of woody tree types, typical of what we would find in landscapes in northern Utah. The next question is, have you developed any tools to assess the temporal change in water use that would flag a 4.0, I can't read it with a flash, yeah.
Have you developed any tools to assess the temporal changes in water use? Example, that would flag that 4.0 LIR user from the example as a person to target for conservation program.
Yeah, I mean, this is, once we run the program and have the values calculated, we can do, we can do queries in ArcGIS to query for high-end users above a certain threshold, but also write scripts that you can enter a threshold that find those people and print it out and separate it out in a separate table with a list, so that you have the information on the property and the owner and all that to be able to go and visit and target.
We have done that analysis in the past, and we found that there are three distinct patterns. You have some that are consistently low, you have some that are consistently high, and you have a large segment of households, at least in our test cases, that are highly variable over time. And part of the variability is due to mobility, people moving in and out, and you're seeing the behavior of different individuals in the same location or at the same property. So one of the things we're trying to distinguish is how much of waste may be due to some infrastructure factors, such as an irrigation system that's poorly designed and inefficient that may remain in place for 20 years or more, and the behavior of the individuals that live in the house using that technology. And so we've been trying to figure out which factors and the locations affect it.
Okay, next question from Doug Bennett. Often, after a series of estimates, you wind up with a negative water use value. How do you deal with that?
Yeah, the negative water use value was a characteristic of when Logan only read the meters twice a year manually, and so they would estimate an amount, and when they finally did another read 6 months later, if the person had been using less water than what they had estimated, they would give credit back by having a negative value estimate. So that's where those negative values come in. It's a characteristic of the time when there was only 2 manual reads a year.
And how we deal with that, we sum the estimated values until we hit the actual read, and if that actual read is negative, when you sum it with all the previous months of positive values, it should remain positive. If not, it's an error.
That's part of the working through all the data errors in metered data that we've been wrestling with. There are houses that are sometimes vacant too, that have no use for some periods of time. We have high rental properties in Logan with student populations, and so we're seeing some of the effect of that in water use.
Okay, another question from Doug Bennett. How do you determine the landscape area and type when obscured by tree canopy?
Well, that's a good question. We've accounted for that in Logan back when we did the original flight in 2004. We did a early spring flight as well, before the trees had leafed out, but after the turf grass had greened up. Okay, so by doing that additional flight at a higher resolution, I might add, at 0.5 meter pixels, by comparing that imagery to the imagery late summer when everything's leafed out, we were able to establish that in Logan, on the typical neighborhoods, most trees had about 34% turf grass growing under them. Okay, so we used that average value and added back in 34% turf grass in the calculations to account for that extra vegetation under the canopy.
Okay. Next question from Morgan Zealous. It may have been stated, but did your group make your own classification system for landscape, or did you use a standard?
Yeah, we were using Erdas Imagine as the image processing software, so we used the supervised classification technique tools and the maximum likelihood scheme to classify. I might add that because of the high resolution of the data, there's tremendous bidirectional effects, because you have a tree that will be illuminated on one side and it will be shaded on the other, and it's the same tree. And so you end up having a lot more signatures needed to explain the variability in the image, and after you do the classification, you have to recode things and group them up into the categories that you're looking for, which is the grasses separately than the trees and shrubs. So that process was done separately in Erdas Imagine. Okay.
Doug Bennett asked, has Logan utilized any of this info for conservation programs?
We did interventions. We delivered water check programs to households in 2004 and 2005. In 2004, we delivered them on a voluntary basis, and what we did is offered people water checks, and in connection with that did interviews and follow-ups to see the response. We noticed in 2004 that most of the people that volunteered for that conservation program were already fairly efficient, and that, as the field worker said, she was preaching to the choir. And so in 2005, we went in, and we didn't have this whole tool developed at that point, but we had a modified version of it where we identified locations with high use over a 3-year period, and we then sent letters to them in 2005 and offered to go and do a water check, but brought to their attention that they were using more than the average amount. We worded it kind of carefully that way. And we had quite a few people call in. It was news to them. It did give some reinforcement to our hypothesis that there was a lot of innocent overwatering going on, and the information itself that they were using more than they needed seemed to be motivation for them. They didn't want to be considered wasteful, and they wanted to do the right thing. So we always, in interacting with people, have been really quite pleased at their receptiveness to some of the information. So we are hoping to work with more cities on using it as a targeting water conservation program targeting tool, and that's one of their main interests.
From Scott Davis, can you expect less water use from mature landscapes with greater tree cover shade versus landscapes with thicker sod and less mature tree shade?
Yes. Our analysis that we did in Layton over 10 years ago, where we were studying the conversion of irrigated ag land to urban and new neighborhoods, we found by looking at those young neighborhoods, which were mostly turf grass, and comparing them to other neighborhoods in Layton that were well established and had mature trees and shrubbery and a lot of shade, that the water use was a lot higher in those younger neighborhoods with exposed turf grass that are trying to establish the turf grass and shrubs. There's other secondary reasons as well. Usually the new neighborhoods are the ones that have the automated sprinkler systems that we have found that people can irrigate more efficiently.
Yes.
And while in some of the older neighborhoods, though they might have sprinkler systems, a lot of them you have to go and turn the sets on manually and turn the valves on manually, and then you've got the other extreme end of the hose draggers that are dragging their sprinklers around and really paying attention to how much water they're putting on, because they don't want to spend a lot of time doing it, or at least minimize the amount of time doing it. So you have those backdrop reasons on top of the physiological plant factor reasons.
Interestingly enough, we did make that recommendation at American Planning Association meeting in 2005 that if they really wanted to save water in a drought, don't let people use their automated sprinklers. And a city in Florida actually used that as a conservation tool. And they did experience savings. They just didn't let people use their automatic irrigation systems. And we're pretty sure that that would be at least one tool in a severe drought that you could use. If people, they could water, but they'd have to do it by hand. And they tend to be more in tune with the landscape need when they're out there interacting with the landscape and seeing it firsthand, and the automated systems prevent that oftentimes.
How do you deal with parcels that have multiple meters? Is the data combined by parcel? And the answer to that is yes, if you can. The example I'll use is Weber Basin. They've been sending out reports through this software, monthly statements, which I'll pull up one to show. But they have a few parcels where they do have multiple meters, and there's an import routine to get any of the data into a format that you need. Just a moment, I'll show you that too.
There are a lot of oddities with the meters. Logan had gone through a long period of a couple of years trying to update all their databases on their meters. sometimes we find people who own double lots, but they only have one with metered water use. And they're actually irrigating a much larger portion because they own both lots, maybe next to each other. And so we see this as an initial scanning tool, but then clearly in delivering conservation programs or going for more site-specific analysis, you'd be able to identify some of those factors that could be giving you, in essence, the wrong signal about overuse.
This is some code written in Visual Studio, which is what the program's based off of. And this is about the size of a routine you would need to import your metered water data. And in this import, you just take the account number, it assigns which account number each meter goes to for the Weber Basin parcels, and it will sum it to it on a monthly basis.
You have a sample of the report.
I do, and I'm pulling that up.
We might add that in Weber Basin, what we're doing a study there, it's particular to Utah. It's a secondary water system where they're irrigating the landscape with canal water, not treated water. And this has got to do with when it was converted from ag to urban a long time ago, and the water rights got transferred along with came with the land. And the charges for this water are usually once a year on the tax bill. So they don't, what Weber Basin now is installing automated meters, measuring meters to measure how much water is being put onto the secondary system. Not right now to charge anything, but just to observe how much water people are putting on their landscape through these systems. And we've been working with Weber, and what you see now is one of the statements. You'll see down on the graph, the bar graph, where we've already sent out two sets of statements, one in May and one in June. This is based on a read on the middle of the month through a wireless system. And we apply the same procedure as we did in the Logan case with the flyover data and using this meter data to estimate the amount of water that's being put on and coming up with a landscape irrigation ratio. And this is sort of the statement that's sent out every month to this group of people of about 1,000 meters that have been installed. Do you want to add to that?
If you look at the graph in this chart, you'll see that May has no use. That having no blue column there indicates no use for May, so that they did start irrigating after May 15th and on into June.
And the yellow bar graphs are our estimate of water need based on 30-year average reference ET from stations in the area.
So by the end of the season, the green and blue bars will be filled in. This is a test case that we're running with them. This is the first secondary pressurized system that they've converted to meters, and we're using this as a test of the information delivered to them absent a price signal. They aren't charging them based on volumes of water. They're charged just for the delivery of the water on their property bill. And we're getting feedback from them over the course of this whole season, then we'll survey them at the end of the year about what they learned about their own water use.
We realize that it is already 3 o'clock, but we're still going to answer a few questions. From Morgan Zealous, are there any publications out related to the software or the assessment of the Logan Conservation Program?
Yeah. And we can provide you those by email, PDFs, if you email us requesting them.
Did we post the email? Sure.
Okay.
Yeah, there's email.
Okay.
From Sherry Vogel, when and how will the software be made available to municipalities? Good question.
Yeah, well, one of our objectives of coming to the Front Range and presenting for different municipalities here in this webinar as well. And what we're doing in the Wasatch Front in Utah is to get additional feedback to make the software more robust and more flexible and to attend more needs. Because of this, we've gone through the university appropriate office because they're concerned of intellectual property, and once we get those issues solved, the idea is to install the software with municipalities who want to work with us and help mine their data and allow us to do research with their data as well. So we are interested in collaborating with other municipalities.
Working on some licensing agreements through our university.
Next question from Morgan Zellis. Have you done any sensitivity analysis on your data? Have you done the analysis with and without the buffer, or with using a more simple classification system, grass and shrub only? What were the results, or anything else? I am interested because although I would hope to go into as much detail as you have with your GIS analysis work, it is time consuming. Are there parts of the pre-analysis that seem less important to the LIR than others?
Yeah, we are working on a sensitivity analysis right now, actually. That's a very good question because simplifying it might still be a way to use the software with other data sources that are not flyover data and simplify the process, but still get enough reasonable numbers to identify the high-end users, which is the ones that you would want to identify and target for conservation practices.
From Todd Adams, how do you determine the secondary water use for the systems with no meters?
Well, at this point in time, we're only working with the metered properties, of about 1,000 meters. This is a pilot program from Weber Basin, and they wanted to gather the data to see how the typical secondary water meter user is using the irrigation water and how much they're applying. I think the results of this effort this summer will lead to possibly some more educational opportunities working with these folks, and whether they're going to continue installing meters on all the other secondary properties. I think we're done with questions, are we?
Okay. We skipped just one question. It's from Doug Bennett at the beginning. When do you collect image data season?
Yeah, ideally at peak leaf out. Sometime in the end of July or August is when we go to collect the imagery to get the best contrast between the trees and shrubs and the grass.
A follow-up question from Todd Adams. Do you factor the summer water use up at all of the winter indoor use?
Yeah.
Let's see, we sum the winter use for, if you're doing the indoor use analysis, like in Logan, we'll sum the winter use up the months that are not the growing season and subtract the proportional amount applied to the growing season. And that's how we come up with the number for their outdoor use. From Laura Wing, how do you correct for other outdoor uses such as swimming pools?
In the past, we've asked them, that's been a survey question that would get at different uses, but the aerial imagery will generally show us if there is a pool in the yard. And so we've seen that in some of the Weber Basin areas. But
it hasn't been an issue in Logan because there's hardly any pools in Logan. The season is too short.
yeah.
Well, without any further questions, I think we're going to wrap it up here. I'd like to again thank Joanna, Endter-Wada, for Neale, and Clay Lewis from Utah State University for participating in a Western Water Assessment effort and for giving us this pretty interesting webinar. Hopefully, you'll have, you saw the contact information. We'll also post this presentation to our website, and you saw the URL earlier, www.colorado.edu/webinars.html.
And for those of you that have participated in this webinar, we're sorry that you weren't in the room with us because we would have liked to have had more of a discussion, and we have actually a little information sheet that we would like to collect some information on you that will help with this refinement of the software. So we will be sending that to you, either in the mail or email, depending on the information that we're able to pull down about who called in. And so please be expecting to see something from us. It will have our contact information on it, and our contact information is also on the PowerPoint slides that you'll see. So we'll be in touch with you. We really do appreciate your participation.
Thanks, everyone, and apologies again for the technical problems.